All right, so now we're getting into some more complicated rational equations. All right, example 2 tells us to solve each equation. Be sure to exclude any extraneous solutions. All right, our first equation is 2 over p plus 3 over 8 equals 5 over 4p plus 12. So we're dealing with a rational equation, right? We see that equal sign. To solve rational equations, the strategy is to multiply both sides by the LCD. But when you have polynomials, in order to figure out the LCD, you have to factor. Right? P plus 3 can't be factored. Right? There's no GCF to pull out. It's not a difference of squares. It's not a trinomial. This is it. This is as simple as this denominator gets. 8 is 8. Okay, but 4p plus 12 has a common factor that you can pull out. Right? There's a 4 in common. If you pull out a 4 from 4p plus 12, you'll be left with p plus 3. Okay. Then you can build the LCD by taking each factor the most times it occurs. Okay. So if you look at this denominator, you have a p plus 3, and this denominator has a p plus 3, so you know the LCD is going to need a p plus 3. And then this denominator has an 8, this denominator has a 4, so you know the LCD is going to need the bigger, right, an 8. So now you take the LCD and multiply each term in your equation by it. Let me write out what you get. So I've multiplied each term by the LCD, which is 8 times p plus 3. Remember, this is 8 times p plus 3 over 1. So this 8p plus 3 is in the numerator, which means I can now reduce the p plus 3 factor with the p plus 3 factor to 1. Okay. Similarly, in the second term, I have an 8 in the numerator, an 8 in the denominator. Those can be reduced to 1. And finally, in my last term on the right side, the p plus 3 terms reduce to 1. And then 8 over 4 reduces to 2. So altogether, I have to multiply this 8 times this 1 times this 2 in my first term. I have to multiply this 3 times this 1 times this p plus 3 for my second term, and I have to multiply this 5 times this 2 times this 1. Okay, all my denominators have been cleared. That's the point of multiplying by the LCD. Right, if all your denominators are not gone at this point, you've done something wrong. Right, but let's go ahead and write out the result of our multiplication here. So from the first term, 8 times 1 times 2 is 16. From the second term, 3 times 1 times p plus 3 leaves me with 3 times the quantity p plus 3. And on the last term, 5 times 2 times 1 is 10. Right, at this point, we have a linear equation. Okay, you need to distribute out the 3 and then isolate your variable. So let me write out all the steps for that very quick. So here's how you would solve 16 plus 3 times p plus 3 equals 10. Distribute out the 3, collect like terms. 16 plus 9 is 25. Get your numbers on one side, your variables on the other. Divide to isolate p. So in the end, you end up with p equals negative 5. Now you have to be careful. You want to check and make sure that negative 5 doesn't give you undefined, doesn't give you an undefined fraction in the original equation. Okay, but if you plug in negative 5 to p plus 3, it's not 0. Negative 5 plus 3 is negative 2. And if you plug in negative 5 to 4p plus 12, you get negative 20 plus 12, which is not 0. So there's no problem. This negative 5 does not make any of your denominators 0, which means it's not an extraneous solution, it's an actual solution. So we'll box it and move on. Okay, so moving on to part B. This equation looks like a beast. We have 4 over t plus 2 minus 13 over t squared plus 6t plus 8 equals 3 over 2t plus 8. So we have an equation with fractions, right, with rational expressions. So our strategy is to clear those denominators out by multiplying by the LCD. Okay, which means we have to find the LCD. We have to determine what the LCD is. How do you find the LCD for a bunch of fractions? Well, if you have polynomials in the denominator, if you have plus or minus signs in the denominators, you have to factor. All right, so I'm going to factor t squared plus 6t plus 8. Hopefully you've been doing this long enough to see that this is t plus 2 plus 4. Okay, so that's a trinomial. You'd factor it using your boxes. Right? Now, on the right side, you have 2t plus 8. The only way to factor that is to pull out the GCF, which leaves you with 2 times the quantity t plus 4. So we can determine what the LCD is pretty easily now. We need a t plus 2. Right? We also need a t plus 4, because this fraction has a t plus 4, and so does this one. But we haven't included everything yet. We haven't looked at our constant factors. Right? We did the t plus 2, we did the t plus 2, t plus 4, but we haven't worried about the 2. So that's going to contribute to our LCD right on the outside. So this is what we have to multiply everything by to clear the denominators. Let me go ahead and write that out. Okay, so each term of our original rational equation has been multiplied by the LCD. Remember, you want to think of this LCD as multiplying in the numerators because the denominator is just 1. So this can be reduced, the t plus 2 and the t plus 2 turn into a 1. The next term can be reduced. The t plus 2 factor and t plus 2 factor give you a 1. The t plus 4 factor and t plus 4 factor also give you a 1. And finally, the t plus 4 factors go away, and the 2 factor goes away. So if you notice, all of our denominators have been reduced away. So now we just have to focus on what we have left. The first term left us with a 2 times 1 times t plus 4 times 4. The second term left us with a negative 13 times 2 times 1 times 1. And then the final term on the right side left us with 3 times 1 times t plus 2. All right. So let me write what we get after we do our multiplication. So in the first term, the 2, the 4 got multiplied to 8, and then that 8 has to get multiplied by the entire quantity t plus 4, so we're going to have some distribution to do here. The negative 13 and the 2 got multiplied in the second term to give us negative 26. And then finally on the right side, we had the 3 and the t plus 2 quantity getting multiplied. All right, so at this point, all our denominators are gone. This is a linear equation. Right, we've been solving this forever. Distribute everything out, collect like terms, yada, yada, yada. All right, so let me write it out real quick so we can get to our solution. So here's the work you would have to do to solve the linear equation. Right, you would distribute out the 8, distribute out the 3, collect your like terms. 32 minus 26 leaves you with 6. Get your numbers on one side and your variables on the other. The 6 moves over, the 3t moves over. So altogether you're left with 5t. 6 minus 6 is 0, so you have 5t equals 0. That's okay though. Divide both sides by 5 and you get t equals 0. Okay, now the final question you should ask yourself, is this an extraneous solution? Okay, does the value, the variable value of 0, t equals 0, does that make the original equation undefined? Well, if you plug 0 in here, 0 plus 2 is not equal to 0. So it's okay to plug 0 in the first term. If you plug 0 in here, 0 squared plus 6 times 0 plus 8 is not 0, right? Because this 8 will be left over. And if you plug 0 into the last denominator, 2 times 0 plus 8 is not 0. Okay? So this is a perfectly good solution because it does not make any of the denominators 0.